So hello everyone. Thank you for taking time out and being here today. Today we will show you how a joint solution with Rebaca Technologies ABot and Aarna Network multi-cluster orchestration platform will let you choose an optimal 5G core network. Before I introduce our speaker for today, request all of you to keep your questions and queries post the discussion. And also I'll be recording the session, so we'll be sharing with you all. So this is going to be our agenda. Introduction to AMCOP and ABot by our speaker, Shriram and Samir. The technical demo will be done by them. And the last session, as we always have, is the question and answer session. So our speakers for today, Shriram Rupanagunta, co-founder and SVP Engineering, Aarna Networks, and Samir Chatterjee, Managing Director at Rebaca Technologies. Yeah, hi Shriram and Samir, welcome.
Thanks, Priya.
Yeah, so you can take over from here. I will stop sharing my slide and you can start.
Sure. All right. Can you see the slides, Priya?
Yes, I can see, Shriram.
All right. I hope you started the recording also, right?
Yes, I started.
Okay. All right. Hi, everyone. As per the agenda, we'll do a quick introduction to the two products, AMCOP and ABot. So I'll go through the AMCOP product details, and then Samir will go through the ABot, and then we'll go through the demo. So we'll not go into a lot of details on the products because that's not the main agenda of the webinar. But if any of you are interested, we can take up the questions towards the end, or feel free to contact us. All right. So again, a quick introduction to the problem statement of what AMCOP tries to solve. Right? So essentially, what the stress on the network service composite application management explodes by about 1 million times, and that's what we believe in the 5G and edge computing. And in order to solve that, there are 3 areas that we look at as issues that need to be solved. So one is the lifecycle management. The second is the orchestration, and then the third is the service assurance. Right? So in each of these cases, the complexity of the problem goes up because of the 2 things. One is the number of edge sites. For example, if you assume about 1,000 edge sites and about 1,000 application instances, that's how we come up with that million number, 1,000 times 1,000. So essentially, on all the 3 areas, we believe that the complexity of the management, application management, is huge. Right? So again, the purpose of this discussion is not to go into a lot of the details of that. So I'll not go into the nitty-gritties. But essentially, these are the 3 areas that we'd like to kind of bring your attention to, which is orchestration, lifecycle management, and the service assurance. Now, the solution is what we come up with is AMCOP. What AMCOP does is essentially solves these three problems. One is the orchestration, which it does by doing intent-based orchestration. It also does the lifecycle management of these applications, and it also enables you to create real-time policy-driven closed loop. And in fact, for today's demo, that's really what we're going to be talking about. How that particular feature can enable you to design optimal 5G networks. And again, going into the little bit of a detail on what AMCOP does, there is a lot of confusion in the industry about the term orchestration, because they use it in multiple contexts. So what we believe in is that there are 3 levels of orchestration. So one is the infrastructure orchestration, which we showed on the right bottom. And then there is the the resource orchestration, which is what something like Kubernetes solves. And then there is AMCOP, which is the application and service orchestration. So essentially what we'll be focusing on for AMCOP is really the top corner, which is the application orchestration. So this is again a quick recap of what AMCOP actually does. Again, I will not go into all the details of this because that's really not the purpose of this webinar. But I'll just give a quick recap. Some of you who might have attended the previous sessions might have seen this. So essentially, there are three blocks that we show in AMCOP, which is the service orchestration, lifecycle management, and the analytics. So for the orchestration, we use one of the open source projects from Openness, Intel Openness project called AMCOP. For those of you familiar with ONAP projects, this was earlier also part of ONAP. In fact, it still is part of ONAP. It was known by a name ONAP for K-days. So it's essentially the same thing, which is now renamed as AMCOP, and now it is part of the Openness open source project. The second project that we use is from ONAP called CDS, Controller Design Studio. And that's what we use for the lifecycle management of the applications. And the third block in AMCOP is what's called as Aarna Analytics Platform, AAP. And for this, we use a variety of projects from ONAP, mainly the DCAE and some of the related projects. So these are the three main open source initiatives that we use. And then we've built a user interface on top of that. And the interface also supports the REST interface. So it supports both the GUI through browser and the REST interface. And for the analytics, for building the analytics pipeline, we use the Google CDAP project, which was also part of the ONAP DCAE project. And then there are a few other CNCF projects that we are in the process of integrating, such as Prometheus, Fluently, Jaeger, and so on. And then there are some proprietary value adds that we are looking at, such as network slicing, and then the ORAN, non-real-time break, NWDAF, and so on. And again, as I mentioned, we're not going to go into the detail of each of that, but this is just to give a quick overview of the AMCOP project, which is used in the current demo. And this is the last slide on AMCOP, which is really the roadmap of what we are looking at. So we are planning to add the workflow engine, which will enable customers to onboard their own workflows. And there will be some workflows that we will support, such as network slicing. And there are a couple of others which are non-real-time RIC and NWDAF, and then the CLI interface, which are in our roadmap, which we'll be supporting shortly. So that's a quick introduction to AMCOP. It's more of a recap than an introduction because there are a lot more details to this, which we don't have time for today. So with that, I will go into the ABot introduction and turn it over to Samir to go through and give an introduction of ABot.
Thank you, Sriram. Thanks everybody for joining the webinar. So like Sriram mentioned about the orchestration and the closed loop, one of the key elements that you have to look at when you are trying to automate is to validate the setup that you have, whether you have some device under test or you have some emulators. Now, what ABot is a differentiator with respect to some of the other emulators is if you're going to do a closed loop, it's the network, what you really need is to orchestrate the test, not an orchestration like mentioned, it's a heavily used word. So by test orchestrator, it's like you have to execute the test cases. You have to then collect all the different statistics from different infrastructures and the ACTs, and then you have to analyze them, and then you have to feed it back to some decision engine. All that needs to be orchestrated in an automated fashion. Then and only then you will be able to go ahead and configure something, try it out with some end-to-end use cases, then validate that whether it actually worked, and then reconfigure back or do your the usual situation to make sure that this particular network setup is going to satisfy your use case. And again, I don't want to get into too much of ABot. So can you go to the next slide, please, Sriram? So just to give you a quick background, how we are going to use ABot in this particular demo. ABot has the ability to emulate any 5G or 4G component. So we would use a 5G network environment. ABot has also the ability to pump IP traffic of any type of traffic, so that you can go ahead and validate to make sure that you are able to execute these interop test case, performance, or integration. So the objective is you're trying to set up an environment and then run these test cases. One of the challenges that you get in is when you are running these test cases, if they are very complex to understand, then creating these use cases becomes very difficult. So trying to have a very simple way of describing these test cases enables you to create different application-specific use case, which is what we will show with using ABot. Now, once you run this test case, then we would use ABot to analyze the different procedures that were executed, meaning the HTTP procedures, the messages, the events, and then the KPIs in terms of infrastructure, mobility, those kind of things. We'd also look at in this particular demo, we wouldn't get in, but ABot also has the ability to give you, product maturity and build by build analysis, because it analyzes the different execution maturity across builds. See, it has the ability to compare. It also has the ability to understand missing test vectors. So we are not going to get into too much of that aspect in this demo. ABot is completely cloud native. It's one of the things that we would see, that we have extensive REST API support, which allows us to integrate with other third-party orchestrators like this AMCOP or any other application, so that even if you're trying to integrate with some other application to do some sort of an analysis and test case execution, easily able to do that. Can you go to the next slide, please, Sriram? One of the advantages that you in the demo also you will see, ABot stacks are very lightweight, which allows us to deploy these stacks using an orchestrator, wherever it might be, across different edge platforms, different varieties or different capabilities of edge platforms, operator platform, or even public cloud platforms. So, which is very, it's kind of, it's advantageous, because like we'll see in this demo, what we would be using a variety of different, products, and the missing pieces can easily be filled with this ABot stacks. And we have, if we go to the next slide, Sriram, please. I will just, can you go to the next slide, Sriram? So we have extensive coverage for 4G. So we have all the different 4G nodes that ABot can simulate. And similarly, if you can go to the next slide, please, and for 5G as well. So along with the ABot emulated stacks that can run on any part of the network, the ACUT can also coexist, which is what we will see in the demo as we'll execute the end-to-end test case, analyze it, and go through. With that, let's maybe jump into the next set of describe what we are going to show in this demo. I think Sriram has kind of described the problem, with 5G. One of the biggest challenge is 5G brings a lot more nodes into the equation and makes this, configuring and makes this setting up and making sure that that everything works properly very difficult. So even different aspects of configuration and security setting for 5G are quite challenging, and the different combinations that exist are huge. So without having to go through a proper use case validation for different configurations and combinations, deployment becomes a big challenge. So what we are going to showcase is with this AMCOP and ABot working together. Can you go to the next slide, please? What we will show is you can automate that entire process by going through this closed loop repeatedly and be able to come to an environment or a setup that meets your configuration. This is actually not just that aspect, but also to understand how would your network work under different configuration. So when your network is going to operate live, based on the different KPIs that you're collecting at that time, which you are obviously going to be sampling at different rates and all, you'd be able to determine how is your network functioning and can build advanced models around it. Can you go to the next slide, please? Sriram, please jump in and explain, if you have things to add to this. So, we read about autonomous network, and that's one of the big buzzwords around in the industry, and everybody is really looking for how to correctively, get your network into the right configuration. So what we will demonstrate is the ABot, and AMCOP together can showcase this demo where we will configure, execute. So AMCOP would be used to configure, the 5G network in this particular case. It will be both a combination of bunch of different device under test, system under test, and ABot node that will be deployed into an OpenStack environment and a container environment that's you will see in the demo. We would run some end-to-end 5G test scenarios, and these would be these ABot feature files we call test cases. It's actually an end-to-end use case that we'll run. We would go through the mobility and the infrastructure KPIs, and then AMCOP would analyze and determine, and then we'll see that how we are going to be reconfiguring this particular setup. The next slide would kind of go through the different steps for easy, understanding. And maybe what we'll do is maybe we can go to the slide after and show the demo architecture, and then we can come back, Sriram. What do you think? That might make sense. Yeah. So you want to go through this demo configuration that we would showcase?
Sure. All right. So this is essentially what is being done in the community, in the Linux Foundation networking community. It's an ongoing demo. We keep adding features to this. So this is the one that was also demonstrated in one of the ONAC events that some of you might have seen. So I'll quickly go through the configuration of this. Starting at the top, the orchestration is done by AMCOP, which is right at the top, which is also running as a cloud-native application on one of the Kubernetes clouds. And then at the 5G, the box at the bottom is running on Red Hat OpenShift. Right? So that's the NFVI cloud that is used for the 5G functions. And for this demo, and also for this LFN demo that I mentioned, the 5G core that's used is from Altron, and the emulator, which is shown at the leftmost of the picture, is from Rebaca, and that's what we are going to be focusing on for this demo. So the GNB emulator and the U emulator is done by ABot. And then there are a few other components involved for the firewall from A10, and also the SD-WAN from Turnium. So these are all the components that are involved in the overall demo. But for the purpose of this, today's webinar, we'll be focusing mainly on the ABot, the 5G core, which is the Altron, and also the orchestrator, which is the AMCOP at the top. So that's really the configuration. And the closed loop that we're going to show is essentially the events going from the ABot, which is from the leftmost portion, into AMCOP, and the AMCOP making configuration changes required, and also running rerunning the tests. So that's really the configuration. So with that, let me go back to the previous slide, and if you want to add anything before we jump into the demo, Samir?
Yes, so what I wanted to say in this thing, Sriram mentioned, what we will do is we will go through kind of like, if you may think, 6 distinct steps. First, we would configure the entire setup for a particular configuration. And this configuration is going to be with some limited capability in terms of horsepower. And we would run, first we'll run a functional test to make sure end-to-end, everything works fine. And, we'll go through like a ARCA registration, 5G. And then we'll see that it's kind of everything is working. Then we'll run it with a minimum load, the step 2, which is 100 EV, which is really not much, but we'll go through that. And when we run this 100 EV, we'll see how we are able to run it, but not all the use cases are running properly. We'll see how we are seeing some of the UEs are not able to go through. There are some the CPU, the memory, all those are reaching higher capacity. So and then these would be shown in terms of the KPIs that are being collected. Those would then be fed back as the step number 3 into the orchestrator. which then makes a reconfiguration on a higher end system with more horsepower, and then we'll run the same use case with even higher load. This time we would try with 1,000 EVs. And we would see that it's, even though these are not very high numbers, but still we'll see that it's passing. All of the UE call flows are going, the KPIs are better, and we'll have a successful sequence. So that kind of would demonstrate that entire closed loop situation that we were earlier talking about. So with that, let's get into the demo video.
Yeah, so just one point that I'd like to add is the events 3 and 6 that are shown here are for those of you familiar with the closed loop, how the closed loops work in ONAP, DCAE, these are the WES events, right? And then on the AMCOP, it essentially has the WES collectors which receive these events, and based on the policy that is set on AMCOP, it can go and reconfigure things. So the other arrows that are shown 1, 2, 4, and 5 are essentially the orchestration and the configuration. The configuration can happen over either a REST interface or netconf, yang. Those are all the interfaces that are supported by AMCOP, which essentially leverages the CDS module in ONAP. So this is how it kind of maps to the closed loop from the DCAE, from the ONAP DCAE. All right, so with that, we will jump to the demo itself. Let me just stop sharing. Okay. Just give me a second. So I'm just trying to share the video.
I can see on the screen demo use case, that slide.
Yeah. Okay. Let me... Yeah, just give me a second. Should be able to share it now.
Sure.
Okay, can you see the screen now?
Yeah, I can see.
All right. So just to kind of map it back to the what we've shown. So the first part of the demo is the orchestration. So where we show how we orchestrate the 5G core. So in this case, it's the 5G core from Ultron. Um, the NFVI, the Kubernetes that it runs on is OpenShift. So it actually shows all the GUIs in the demo. It shows the OpenShift, followed by the NGC, which is the Ultron 5G core. And then it jumps to the actual demo, which is where we run the ABot tool. And that's where we show the behavior before closed loop and then after closed loop. So let me walk through the steps. So in this case, you can see that there are no pods that are running other than a database pod that's running. So the GUI itself is the Red Hat OpenShift GUI. So you just see that there's a CouchDB that's running, and the GUI that's running here is the GUI for the AMCOP, which, as I mentioned, is also called as one app for KDS. So the first step here that we're showing is registering the clusters. So in this case, the cluster is the OpenShift cluster, which is being registered. And again, this is the orchestration piece, which is really not the focus of today's webinar. So I'm not going to talk about this, but essentially here what we're doing is registering the clusters and also creating the intents so that you can orchestrate the 5G core on the OpenShift cluster. So we have done that. We've registered the cluster. And the registering essentially involves providing a configuration file, Kubernetes configuration file. And we are also setting a label for it so that you can mention where you want your applications to run. The next step is to create what's called as a composite application, which is essentially a service. In the one app terminology, that's a service. So we're creating a service called NGC, which is running on the NTL lab. And the next step is to add applications to the service. So essentially, this is what enables you to orchestrate these applications on different clusters. So in this example, we are just showing one OpenShift cluster where all of the NGC containerized functions are running. But in reality, it could be hundreds of thousands of those clusters. So here we just have, for simplicity, we just have one application. That's where we package all the 5G core functions. So it's one service, one application is what we're showing here. And the next step is to create what's called as a placement intent. So what the placement intent does is it enables you to specify where you want your applications to run. So this is really the intent-based orchestration that we talk about in AMCOP. So here we specify the intent. And then we add the application-specific intents. So there is a generic service intent, and then there's an application-specific intent. So in this case, again, there is a single application. It's a very simple. So there's just one cloud or one cluster, one service, and one application. So it's a very simple configuration. But in reality, you can imagine that this can be thousands of clusters, and each service can have multiple applications and so on. So that's done. Now what we are creating what's called as a deployment intent group, which is really like a service instance. So now that you've created a service, you're creating a service instance. So now this is what is going to instantiate these CNFs on the OpenShift cluster. And you can also mention the override values, which is again, like a day zero configuration. So in this demo, we are not showing all of that, but in reality, you can also set your day zero configuration, which is also called as a profile or override values. So now we've created the intent group, and now we are adding the intents. So this says, which cluster you want this to run on, and what are the network controllers that are required. And again, I'm very quickly going through it because that's really not the main focus of today's webinar. So now the intent group is instantiated. So you can see that now the 5G core is running. So now you can go back to OpenShift and see that all these pods are running. Yeah, so you can see that all the 5G core related pods are all running in this namespace NSNBC, and they're all in the running state. So essentially, at this point, you have the 5G core that's running. So now we can start the ABot emulator. Yeah, so in between that, there's one step which I missed, which is the UPF. So this demo also has a UPF, which is a hardware-based UPF from a company called Kaloom. So their UPF is a hardware-based UPF. So that's in the terminology of ONAP or AMCOP. It's a physical function. It's a PNF. Right? So there is no real orchestration as such, but you can of course configure it. You can configure various parameters of this PNF. So again, in this demo, we are not showing the configuration of this Kaloom UPF. So it shows the configuration of of the UPF and various interfaces like N3, N4, N6, and so on. So this is the GUI of the Kaloom that we're showing here. Right. So with that, we now come to the actual code demo that we want to show, which is the ABot tester, and what it can do, what kind of tests it can run, and how it changes the behavior based on the closed loop. So Samir, you want to start with that?
Yeah, sure. Thanks, Sriram. So yeah, just go ahead, play it, and you may have to pause, play in between. So what
Sure.
we are seeing, this is the front end. Just pause it, please. This is the front end for ABot. And it has, for some reason, your screen's getting dark. I don't know whether it's mine or any of them. You'd see that these test cases that are on the right side, they are very English-like, given, when, then, and the parameters are very simple to understand. So on the left side, we have these test cases. We are going to look at the 5G test case, and then we are going to run our 5G registration test case. So go ahead, run this. This is the first feature file that we'll execute. And in this one, we would go ahead. Yeah, I think the screen is dark and blurred, Sriram. Oh, there it is. I don't know why it's here. This is better for some. So once we execute the test case, and now we are executing it, and so it's first doing our setup, and then it will do a registration. We are seeing the different packet captures that are done, the uplink, downlink bandwidth, and then after this registration setup, we are going to do a registration, that ARCA registration. And can you pause it, please? So, oops. All right, no problem. Yeah, just, again, the screen's for some reason getting very blurred and dark. I don't know. Can you move your
We'll
screen
pause
mouse
it.
down?
That's what happens, I think.
Yeah, I think the mouse somewhere. Oh, okay, if you pause it, okay. So,
Yeah.
so then what we are doing right now, again, as you can see, these parameters are like very much like, key value, right? So it's easy for you to change the parameters for the different call flows. So go ahead, run it. We would go ahead and run a registration method. And can you play it, please? And then you will see we will capture the statistics. And this is we are running functional. So we are currently running the functional test case. So it's actually going through the, Sriram, you have to hit the play. Yes. So it's going through the execution, the registration feature file, and the different packet captures and the uplink, downlink bandwidth and all that. And we are seeing these test cases passed. And this is the analytic window. And then we are looking at it and we are seeing that the 5G, you can go ahead, let it play. I think and then the PCAPs and all that, that shows the call flows are, passed, all of it. So now we have authenticated now we are running a load scenario. Can you pause it, please? So so what we are seeing, this is the first one, 100 UE that we are running, and here we are the UI front end has gone through uplift in terms of the look and feel. So it looks a little different from the previous one. So you will see from this one, the middle, it's like the tabs on the top tells you the status of the execution. So after the test bed bring up, you'll see the red sign, which is like it didn't pass all of them. So this is the condition that we are going to first see, and we're going to take a look at that. Can you let it play, please? And then in this one, as we are going to watch the thing play, we'll see that this thing has failed. And when we look at the call flow, we are not seeing all greens. We're seeing reds and greens. And we are seeing the protocol stack is timing out at different cases. So we're looking through the configuration. And then we are seeing that some of these UEs are not, they are not all passing. Some has passed, and then when we can look at the call flow of each one of them, then we look at the KPIs. And when we are looking at the KPIs of different bytes being read, write, and all that, we are seeing some of them, as you will see here, they are kind of in the yellow and green mixed bucket. Now, with this analysis, we are actually feeding all these. This is kind of the UI representation. And what we need to do is this has all REST APIs, and all these data actually it gets fed back to the orchestrator, which then goes ahead and reruns this onto the new configuration with even higher load, which is 1000 EV. But this time the performance and the ladder diagrams that you will see, you'll see there are a lot better results, meaning this is all green and they are all passing. And when we go look at each one of the PCAPs, you will notice that ABot has the ability to parse these using its analytic engine. And you'll see all the PCAPs, so the packets are, all in there, in the green category. In this time, as we see the different KPIs, you notice that the KPI values in terms of different memories that are being accessed, different CPU, let it run, Sriram. The CPUs that are being used. This time you'll see the infrastructure. Infrastructure KPIs as opposed to last time which you guys have noticed that they were not in the green bracket. They were kind of in the yellow and red bracket. Yeah, we still see that the disk right in one case is still on the, not on the green bracket, but in terms of the previous screen, which kind of went through a little bit, can you just go back, rewind just a little bit, where it shows the mobility KPIs, just, yeah, a little bit farther. Yeah, there you go. So it allows you to even look at the control plane and the different attach registration times, and these are all within the success range. And so we are able to demonstrate that once this is reconfigured to a higher system, and the same use case is run with the load, we are getting better result. Let it play. So this is pretty much the end of the demo, that we are seeing the different usage of network and the different types of experience that you see as you go through the entire orchestration. With this, we come to the end of the demo, and now we will open up for questions and try and answer them.
Yeah. Thank you, Samir and Shriram, for the discussion on the solution. Let's give a few seconds to our audience so that they can ask you a question. So I got a question. What is the capacity of ABot in terms of traffic generation and number of UAs?
So ABot is a completely software solution. So you can scale it by adding more VM and pods. So this theoretically, you can actually keep scaling. Give you some idea, on a very simple 16 core 32 GB RAM, you can easily simulate about 100,000 UE and can run 5,000 simultaneous with the UEs doing end-to-end calls. And you can keep adding in terms of either vertically or horizontally, you can scale these.
Thank you, Samir. Audience, you can ask questions directly, or you can just message me here. Okay, one more question has come. What are the resource requirements to replicate this setup?
Yeah.
Shriram, I think this is for you.
Yeah, I can take that.
Yeah.
So the AMCOP and ABot themselves, as Samir mentioned, ABot is a fully software solution, and so is AMCOP, which is a cloud native application. So they are quite lightweight for sort of minimal configuration. So you can run them either on VMs in a sort of a medium sized server, or even as containerized applications. The full configuration will of course require, it will depend on which 5G core you are using, and what kind of scenario you are trying to simulate and so on. So it's kind of hard to give a number for that, but just for the AMCOP and ABot itself can be done even on a single sort of a medium-sized server.
Okay, thank you. Okay, the next question is, what level of integration and customization is required for ABot to analyze artifacts generated by SUT? Samir, this is for you.
Yeah, I can take that. So ABot, as you have noticed through that PCAPs and that I was showing, ABot understand 3GPP specification, and it can process any PCAP. For 5G HTTP v2, because it can be ciphered and mangled, there needs to be an integration with the ECP vendor to understand how they are, how the packets are being saved, captured and being saved, so that then ABot can go ahead and understand. Over to you, Pia.
Yeah, thanks. Does ABot support ORAN?
Yes, I will take that. Yeah, we are building the emulation for the GNBDU and GNBCU. It would be released in June of this year. Go ahead, Priya.
Okay, thanks, Amir. Does AMCOP ABot have to run on Red Hat OpenShift or can also run with Ubuntu systems?
Yeah, I can take that. So AMCOP itself can run on any Kubernetes platform, including OpenShift. The target 5G core will of course depend on what particular vendor supports. Either it's OpenShift or any other open source Kubernetes platforms. But AMCOP and I believe same with ABot as well. They can run on any open source Kubernetes platforms.
Okay. And is AMCOP ETS compliant?
So I think probably the question is HC compliant, right? So,
HC compliant.
yeah. So not fully. There are some aspects of HC which are probably not fully relevant in case of AMCOP. There are some where there is a kind of a partial support, but if you just talk about a general HC standard as such, probably the answer is no. It's not fully HC compliant.
Okay. So the next question is, can I onboard my own analytics applications to analyze the data?
Yeah, I can take that. Yes. Yeah. So you so essentially the way the analytics platform works in AMCOP is that so we use the CDAP as a platform, which enables you to onboard your own analytics application, or you can use one of them that's available. There are some open source and applications that are available, which can be onboarded. Or if the customer is developing, or if you're developing your own analytics application that follows the CDAP specification, you can onboard that. So, so the answer is yes. You can have your own analytics application.
And I get one more question. What interface does AMCOP use to make configuration changes on the 5GC stack?
Okay, so I think during the demo I might have mentioned. So there are two sort of arrows. If you I can probably share the screen again, just so that it's easy to explain.
Yes.
Okay, can you see the screen?
No, it has not come still now.
Okay, you should be able to see it now. Right?
Yeah, I can see now.
All right, so so there are two interfaces from ABot or even the SUT stacks to AMCOP. So one is the events, the KPI events that Samir mentioned. So those are all the WES events. So they're in the WES format. the configuration itself from the orchestrator, or in this case the AMCOP, to the either ABot stacks or to the SUT stacks can be over a variety of interfaces. It can be REST, it can be netconf, YANG, it can even be Ansible, Chef type of interfaces. So multiple interfaces are supported. So that's so essentially the way it works is that there is a blueprint that needs to be created, which is in the terminology of CDS, it's called a CBA. It's a controller blueprint archive. So for the parameters that you want to configure, you need to create a CBA. That's essentially encapsulates what interface that you're going to use to configure these parameters. So be it some parameters in ABot or in the 5G core. So they're all part of this CBA. So there is some work that needs to be done to create this. So it's not something that you can just use right off the bat as off the shelf. So there is some work involved to create these CBA or these templates, because obviously AMCOP wouldn't know how to configure the 5G core that you are using, or if you want to change some things in the ABot stack, it wouldn't know that unless you configure or create these blueprints.
Okay, I am also recording the session, so I will be sharing with all of you. In case any questions regarding this webinar, please do reach to us at info@aarnanetworks.com, priyasi@aarnanetworks.com, marketing@rebaca.com, and anindita.rechaudhuri@rebaca.com. So I guess we can close it here. And I will be sharing the recording session, as well as I'll come up with our new technical discussion soon. Thank you all.
Thank you, Priya. Thank you, everybody.
Thank you, Samir and Shriram, for such an awesome discussion. Thank you so much.
Okay, thank you. Bye-bye.
Bye.
Yeah. Bye-bye. Good day and good night. Stay safe. Bye-bye.